Welcome to this video on PostgreSQL authentication manipulation. You might be wondering how you can bypass authentication with PostgreSQL or how you can limit certain connections to authenticate with your system. If you're thinking about that, you're in the right place. So let's start with authenticating, right? We have a user account called Kyle's, which I'm currently on. Daddy is a pseudonym. So if I say PSQL, I'm attempting to connect to my account, but the pga.config entry for Kyle's database, we don't have an encryption connection. What does that mean? That means that we don't have a connection set up or predetermined to allow Kyle to log in or just bypass login. If you're on a Linux system, we can access the HBA config file by going to etc PostgreSQL, the version number, main folder, and the file should be under main. If you're on a Windows, let's go to this PC, program files, PostgreSQL, the current version, and data folder. This is where it houses your HBA config. If we click on that, we should scroll all the way down and see the current settings within our bash file HBA config. Here's our settings, and I'm going to make this a little bit easy for you. Let's read these connections from right to left. A connection looks exactly like this, telling you how are we going to authenticate with this username on this address into these databases. I'll say it again. How are we going to connect with this authentication method into this username on this address for all these databases? I'll tell you how. For Postgres, look at this example. We're running on an IPv6 port. So currently we're not on IPv4. Right now it's IPv6, and we have a rule where we are trusting Postgres on this network interface to connect to all databases. This can be tested by saying PSQL, you and Postgres. We trust the connection, therefore we log in and bypass the login. Now we got an error for Kyle's. Let's check it again. No config entry for the host. We can solve this problem by copying a line and using it as an IPv6 address. We take this, change the username to Kyle's, and we give them access to all with an authentication of MD5. In this scenario, MD5 is similar to Scram, and it doesn't matter, you can use either one, but I'll tell you the difference. MD5 is a legacy type of authentication style, and it's less trusted than the updated Scram SHA-256. So if you're using production, please go with the Scram and go at your discretion. Now in theory, we're going to log in with Kyle under a password. So we save the HBA config file. After saving the bash file, we have to restart the Postgres system. How do we do that? On Windows, we just go to the PostgreSQL application and restart. Now we can go ahead and log in. Look at that. This represents a positive result for creating a connection within the HBA configuration file. Without this, we couldn't log in. We'll get this error again. Now let's log in with our known password. And the login is a success. Let's go through another scenario. We can do a list of host addresses. So if we had a DHCP network where we're listing all these addresses, 16 IP addresses, we give them access to these two databases. I can't test this right now, but if you're in that scenario, you can go ahead and configure this as a range of IP addresses or client users that have access to these databases or to all databases. But here's the catch. they've got to log in under a known password. Without that, they can't get in. If you want to trust them right away, that's fine too. You can trust them without using a password to connect to the database. Totally on your discretion and what you're using this for. Now, if we want to reject a user from accessing some content, let's go into our PSQL, list the users we have, and we have a user named Jeff. I don't want Jeff to have any access to, I don't want Jeff to access Alice's database or test. So let's create a rule for that. Under our local connection, under IPv6, I don't want Jeff to have access to test or Alice. And the authentication method is going to be reject. This represents that we are rejecting Jeff from accessing these two databases. In addition, Jeff can't access anything else because we don't have a rule for them to access databases under trust or under an authentication method style. So Jeff has access to nothing at this point. If we save this, restart our Postgres, let's quit Postgres, and let's try logging in to a database under Jeff. PSQL, U for the username of Jeff, and a /D for the database of where are we being rejected from? Test and Alice. Let's try Alice. Error, HBA configuration file rejects connection for the host Jeff, database Alice, no encryption. So in short terms, that's saying configuration files rejecting Jeff out of this database. We should get the same result if we were to access test database under Jeff. Same result. Now here's what's interesting. If we gave Jeff access to one database, let's say Kyle's, and we have them trust, we can save this configuration. Let's restart Postgres. Now, Jeff has access to the Kyle's database and it is a trusted connection. Therefore, we don't have to use a password. PSQL, U as Jeff, and the database is Kyle's because Kyle's is allowing that to happen. And we made it to the Kyle's database under Jeff. Now here's what's interesting. We can read the databases that we have under Jeff's account, but what we can't do is access test or Alice because that rule still applies. Even if we can read the data, we still can't access. Let's verify that. We can say connect as Jeff to Alice database. We get the same error. Jeff doesn't have access and is rejected. Same for Alice, or same for test. Jeff is rejected. So that was a quick little tutorial on manipulating and making your connections when it comes to knowing who's connecting to your system and how you can manipulate the connections from right to left. So let's do a quick recap. We found our HBA config file, and every time we alter something in this bash file, this bash script, we need to restart the Postgres system. That way the script restarts with it. And as we read this from right to left, we can use IPv4 connections, we can use IPv6 connections telling by the address, and depending on how it's going to affect us, we're going to say these number of IP addresses, all 256, is going to be trusted as the username of reg user. And they have access to only one database called test. We save the file configurations, restart Postgres, and the changes should take effect within our system. What's most important here is how we affected the local hosts on my own system, where we are trusting Postgres to log in altogether because that's root. We have my own account under an MD5 authentication, which is still prone to getting hacked, but it's not as updated as Scram 256. Therefore, I'm putting in a password when I log in, and Kyle has access to all databases. When it comes to putting different users or databases, you can list multiple databases and users simply with a comma and edit the changes. And that is your quick little tutorial on manipulating authentication with PostgreSQL. If you like this video, please drop a like and a little comment. That way we can keep the conversation going.